Okay. All right, so probability, we're going to skip and do probability. And go back and look at chapter 4 later. All right, so probability. So you already know probability already. Here, let me prove it to you. You're going to roll a dice, or roll a die. What's the probability of getting a 4? What's the probability?
1 out of 6.
Okay, she said 1 out of 6. Agree with that? Y'all thinking that? So the probability. So this is our notation for that. Capital P, and then in parentheses the event that we're interested in. So this stands for the probability of rolling a 4. And you said that that is. So we want to analyze this. So when we have harder problems, we know what we're doing. So let's start with this. So there's two numbers here, 1 and 6. What does the 6 mean? Total.
The total number of possible outcomes.
So when you said total, is that what you meant? Yeah. So total, yeah. So when you roll a dice, there's 6 possible outcomes. So that's what ends up being in the denominator. Number of possible outcomes. Okay. And then what? So now what does the number 1 mean? So in this situation, why do we say 1 over, or 1/6? Why did we say 1/6? Yeah.
Is the 1 just all of the values that you want? Like all of the instances of the value you want?
All of the instances, or the number of instances of the event in question. So when you roll a die, out of the 6, how many of them are rolling a 4? How many are rolling a 4? 1, right? So out of those 6, there's just this one right here that counts as rolling a 4. So it's like of the possibilities, how many are the event described? So of all the possibilities, how many are the events described? In this case, out of all the 6, one of them is a 4, the event we wanted. So it's going to be 1/6. This is the probability. So that's the baseline foundational idea behind probability. So I'll have you do some more here. So work on these. So we said rolling a 4 was 1/4. 1/6, I mean. Okay, so work on these. Check with each other. Sheets are for later in class. This is for your notes right now. Might be one on that counter right there. The dots.
Oh, okay.
The dots. Each little dot is a pin. Sorry. Okay, compare your answers with others.
So two corner pips would be the 4 and
Exactly 2 corners have a pip.
5. Would that be the 4 and the 5?
How many corners have a pip on the 4? Exactly 2 corners have a pip.
Least likely to occur. Second one most, second one would be either one, because it was 1/3. This one was 1.5, so it'll be 2, and then 3, and 4, and then 5. 3 and 4. That's the most likely.
Oh, that word to return to yes. Gotta remember that. Okay, even value. So we're asking then, how many of the 6 are even? Okay. Exactly 2 corners have a pip. So of these 6, how many have exactly 2 in the corners?
2.
Which ones?
2
2 and 3 have exactly 2 in their corners. These have all 4 in their corners. So 2 of those. Greater than 1. 5 of them are greater than 1. Less than 10. All of them. 6 out of 6. Not a whole value. 0 of them. Okay. Okay, so what happens is, so let's get decimal approximations for all these. 1/6 is about 0.17. 3/6 is 5. 2/6. 1/3. 5/6. 0.83. 6/6 is 1. 0/6 is 0. So how do you order these from least likely to most likely to occur? Okay. So this would be first.
Yes.
Okay. And what's next? Rolling a 4 would be next most likely. 2 corners. Even value. Greater than 1. So what are you doing to order them from least likely to most likely? You're looking at what? Yeah, so this number, this probability is indication of likelihood, right? Likeliness. How likely it is. Okay? And so, if we're talking about in the numerator is the number of possibilities out of all possibilities, what's the worst you could do? What's the worst you could do? We've got a certain number of possibilities. What's the least number that you could get out of those? What's the fewest number of possibilities you could have out of a given number of possibilities? 0, right? And we saw it right here. You can't. So can you do any worse than this?
No.
If you're counting, so if you're saying how many of these are our event, then the worst you could do is 0. So can you have a negative probability? You can't have a negative probability because you can't do any worse than 0 out of all the possible ones. Okay? But students throughout the ages have tried to report probabilities as negative. But if you understand what's going on, you would never do a negative because you can't. The worst you can do is 0. And what does that mean, a 0 probability? What do you think, Mackenzie? What does 0 probability mean? What do you think? Mm-hmm. Go out the rest of you. What do you think? Impossible. Exactly. It's impossible, right? Impossible. 0 probability. If p equals 0, it's impossible. Okay? What's the very best we could do? So we've got a number of possibilities. What's the best we could do? All of them, right? Can you have, if the numerator is out of that, how many apply? Can we have more than that? No. If there's 6 possibilities, you can't have more than 6 in probability, right? So the best you could do is that everything like this one, less than 10, everything applies. So our probability is 1. And what does that probability mean? What's that? What's that? And what does that mean? Now, there's a 100% chance. Certainty, exactly. It's absolutely certain to occur. Certain to occur. No doubt about it. So impossible is the worst possible situation. That's probability of 0. Probability of 1, absolutely certain to occur. There's no chance it won't occur, right? So then what does a 0.5 probability mean? Yes, it means 50-50. Well, what does that mean? Most likely. 50% probability means most likely. What do you think? Okay, it can or it can't, but really anything in here is can. It might can or can't, but so specifically, what does 50% mean? Yeah, so it's equally likely that it wouldn't happen or it would happen. So equal likelihood of happening or not happening. Equal likelihood of occurring or not is 0.5. So if you move to the right on the scale, what happens to your likelihood? If you move to the right, likelihood's going up. So up here, say 5/6. What can we say about the likelihood of this event if it's here, 0.83? Is it possible that it won't occur? Yeah. But what? What's that? It's possible, but what can we say? More likely to occur, right? The further you are to the right, the more likely it is to occur, although it's possible it won't. Until you get to 1. When you get to 1, now it's absolutely certain to occur. And when you move down this way, so we had, what, 1/6, which was like 0.17. What could you say about that? Somebody knew. Right? It could occur or not, but it's less likely to, more likely to not occur than to occur. More likely to not occur than to occur. So as you move this way, more likely to occur. less likely to occur moving this way. So it's this probability is this number that gives us a gauge of likelihood. You can't do any worse than 0. That means it's impossible. You can't do worse than never going to happen. And you can't do any better than 1, certain to happen. So don't report probabilities of 1.3 or 2 or 10. Doesn't make any sense. Doesn't make any sense. Likewise, don't report negative probabilities. Doesn't make sense. Okay, so questions on basics here. Okay, so let's look at, here's the summary. We've already kind of written this down. So if there's n possible outcomes, an event can occur in f ways, has a probability of f over n. So that's review. We already said that. Number of ways the event can occur is the numerator. Total number of possible outcomes is the denominator. And that sets up this ratio that could be as small as 0 and as big as 1. And as you move from 0 to 1, the event is more and more and more likely. Okay, so let's do these for your sheet. Work together. Yes, ma'am. I gave you enough. There were more at the end there? You could just write fraction answers if you want. Oh, do you guys know cards? G, less than 9 and greater than 4 in red. So we're going to do the probability of this. So let's do the denominator first. What's the denominator?
52.
So out of possible 52 cards. So what question are we asking? We're asking how many of those 52 cards fit this criteria or meet this condition. Okay, so less than 9 and greater than 4. Let's just do the numbers first. So what numbers What values on the cards are less than 9 and greater than 4?
5, 6, 7, and 8.
She wants 5, 6, 7, and 8. Agree? So 5, 6, 7, and 8 is how many cards? That's four cards. But then it has to be red too, so that's 4 cards. So basically we're saying how many cards are a 5, a 6, a 7, or an 8, and they're also red.
8.
So there'd be the 5, 6, 7, 8 of diamonds. That's 4 cards. And then there's be the 5, 6, 7, 8 of hearts. There's another 4 cards because those are all the red cards. So 8 of the 52 cards meet that criteria. 1, 2, 3, 4 in diamonds. 5, 6, 7, 5, 6, 7, 8 in diamonds. 5, 6, 7, 8 in hearts. That's 8 cards. Does it make sense? Is that what you put? Is there one more you want me to talk about?
About 1E just for kicks.
1E, probability of 0. So anyone come up with an event. So you're making this up now. What's an event that's a probability of 0? Who wants to share theirs?
Not picking a colored marble.
Not, but you, okay, so you pick a marble and the event is that it's clear?
One of the colors.
Like no color.
No color.
Yeah, so you pick a marble and it's clear or it has no color. That's probability of 0 because none of them are. What was yours going to be? Yellow. Oh, okay, good. So what's the probability that you pick a yellow marble? 0. Yeah, go ahead.
I said picking a dice.
Picking a die. Awesome. So you reach in and you grab a die. Okay? That's great too. Anything that's impossible, anything that's not going to happen, anything that's impossible when you reach into the bag and pick one of these marbles is an event that has probability 0. Those are all good. Okay, ready to move on? Okay, so a sample space is a collection of all possible outcomes. So it's not, so now by a sample space we're talking about the list of possible outcomes. Versus what we just were talking about was what? How many possible outcomes. So the key distinction here, the sample space is the list of the outcomes. So the event, this is good. We already talked about this. The event is when you talk about the probability of an event. Well, this is just a long explanation, definition of these events we've already been talking about. Okay. So just the main thing here is that the sample space, when you say the sample space, you don't mean how many possible outcomes, you mean the actual list of all the outcomes. Okay, so here's, this is an example of a sample space. Why? Because it's if you flip a coin 3 times and you take all 3 flips together, here are the possible outcomes. This is the list of possible outcomes. You could have all heads. You could have gotten heads, tails, heads. You could have gotten heads, tails, tails. You could have gotten heads, heads, tails, etc. So the sample space is the list. What's the size of the sample space? Right, so the sample space is the list of possible outcomes. Number of outcomes is 8. Number of possible outcomes. So there's the list, and then there's how many things are in the list. Make sure you get those straight. There's the list itself, and then there's how many things are in the list. Okay, so here's a bunch of events. We've already seen this, you know. The event is the marble is blue, or the event is the jack of clubs. Those are all events, and this is some other examples of events. So I want you to do these for your sheet. So A, B, C, and D. Probability of these 4 things. Now you need the sample. You're going to look at the sample space and go through. Say how many of them. Right. The numerator will be how many. Every time you want to use that, you can just use the letter B. So in part B, it's asking for the probability of B. Right. So we can rewrite our probability now. Instead of writing out that whole phrase, I can just say the probability of B, and capital B is that event. The last 2 tosses come up tails. So we go up. So what will the denominator be? 8. 8 possible outcomes when you flip 3 coins. Okay? And then we're going to look at the last 2 come up tails. So we just look at each one, and we want the last 2 to come up tails. So no, 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 no. This one. This one. Oh, no, no. And this one. So you see it's just 2 of them? So 2 of the 8 have tails for the last 2 flips. So what's the probability of that? 1/4, or 0.25. More likely to occur than not, or more likely not to occur? More likely not to occur, right? Because it's less than 0.5. Okay, there's a strong chance, right? There's a strong chance. 1/4 chance is definitely will happen. This is not playing the lottery here, right? This is going to happen a lot, but it's still less likely to occur than not to occur because it's less than 0.5. Okay. Other questions on this example? Okay. So now, probability is very similar to something that we've already done earlier in the course, as you remember. We're taking like the certain number of possibilities and we're dividing by all possibilities. We kind of did something like that before, but not probability. Does anyone remember what it was? Yeah, was it? Yeah, a certain kind of frequency, right? What kind of frequency was it? Remember, relative frequency is really, the calculation for relative frequency is virtually the same as probability because you have the number of outcomes, and to get the relative frequency, what did we get? What did we do? Yeah, we divided by the total. Isn't that exactly what we're doing in probability? So let's just do one here. So I guess I don't have the total. Yuck. Can we do it fast? Let's do it fast. Here we go. Someone check my work. 810 plus 5029 plus 10977 plus 20983. Okay, quizzes are due at the beginning. I announced that. Did you come in late?
Yeah.
Okay. What was one? 36884.
And it went to
65017. 69167. Okay, I am getting 208867. I don't see any mistakes. Is that what you got?
Yeah.
Beautiful. Okay. 208. So let's just do one of these relative frequencies. So let's say the age group, what is this? Number of female hospitalizations for cardiovascular disease by age group during 1 year at a certain hospital. Or, it can't be a certain hospital. That must be worldwide or something. Or nationwide. Okay, so let's look at what's the relative frequency for the 60 to 69 group. How would you calculate the relative frequency for the 60 to 69 group?
36884
Huh?
divided by 2, 867.
And tell me what you get. 0.1, how about 3 decimal places? 176. So there's two ways to look at this, okay? As relative frequency, what are we saying? We're saying 17.6% of the whole group was in this age group. That's one way to say it. So that's relative frequency. 17.6 of all the patients, or of all the female hospitalizations for cardiovascular disease were in this age group, 60 to 69. Okay? The other way to say it is, if you picked one of these people at random, the probability that they land in the 60 to 69 group is 0.176. You see? So it's the same calculation, but it's a little bit different. Relative frequency is saying what percent of the total? 17.6% of the total. Looking at it from the probabilities perspective, it's saying if you picked someone at random, what would the probability be that they're in that group? And it's the same value. It's the same value. Okay? So let's do, how about you do, so notice here. So you could make a relative frequency column, and you would just be finding probabilities of that event if you picked one person at random. Okay? The number is the same. So why don't you do for your sheet, why don't you do A, C, and D. Okay, so again, relative frequency, same calculation as the probability of picking one at random from that group. That's the, so here's the key. One of these records is selected at random. Okay, so this is the number of rooms in U.S. housing units. Frequencies are in thousands. Okay? So let's just let's take a look at this one. Oops. Let's take a look at this. Something's going on with B. So B is the event that the unit has at least 2 rooms. So if we wanted to find the probability of B, we were going to do this directly. What would we do? We're not going to do it, but what would we do if we were going to do this directly? We want the probability at least 2 rooms. What would that entail doing to find that probability? Yeah, tell me.
Adding up all the odd numbers of units together, and then find B with number of units from 1 and 2 and divide it by total.
Okay. For what? 1 and 2? At least 2 rooms. 2 through 8, right? So we'd have to total these up to get the total number of units first. And then what's going to be the numerator for event B? Yeah, you're going to total 2 through 8. Okay? And put that total, 2 through 8, divided by the total of all. Is there an easier way to do it? She says yes. How would you do it?
The total minus 637 on top.
Okay. So if we what is what's called the complement of this? The complement is everything else. So what is everything else with respect to event B? What is everything else? So if it's not at least 2, then what is it? 1. So the complement of B, so not B, is the same as 1 room, right?
Yes.
1 room only. So what if we found the probability of 1 room only? Don't have the total. Could that help us find the probability of B? So what would you guess for the probability of not B? 1 room only. So the probability of not B. Would you say it's high or low? Super low, right? Because it's only 637 of all these many thousands of rooms. So we get a low probability, say 0.05 or something like this, or 0.03. So how could we use that to find the actual probability of B? So we're looking at, this is B, and this is not B. So yeah, so if we were to sum up all these probabilities, what would the sum of all the probabilities be? 1, right? That's what we said with relative frequency. When you add up all the relative frequencies, you get 1. So if these all sum up to 1, and I want to know what the total relative frequency or the probability of these are, then I could find this one and do what? Subtract from 1. I could say 1 minus not the probability of not B. 1 minus the probability of not B would give me the probability of B. So it's 2 ways of calculating the probability of B. Yes, you could add all these up and divide by the total, or you could just take 637 divided by the total, and we know that's everything we don't want. And if the sum of the total is 1, then we can just take 1 minus what we don't want. 1 minus the relative frequency of what we don't want gives us the total relative frequency of what we do want, which is all of those occurrences, 2 and up. Okay, does that make sense without actually calculating it? Does that make sense? Okay, so we'll call it there.